So last day we have done up to 6 model, up to 3 more models are there. So we'll be doing this model. These models are going to help us to solve the problems of application of trigonometry in an efficient manner. Because of that, I have written this in the form of model. Now model number 7. This is a model number 7 we are going to discuss. So actually model are itself some problems, right? So here, what is the problem you see? So I'll draw the figure and then I'll try to tell you what exactly is the question. So this time in the form of question, I will take the model. Suppose this is the horizontal line. This is the horizontal line. And then I have 2 buildings over here, or say tower. This is one of the tower and another tower is here. Last day also we did a model like this. But that time what we did was like angle of elevation only for both the cases. But today what we are going to do is not about the angle of elevation. So here what will happen, I'm just telling you that first let me write the name of the building, then it will be easy for us to refer. This is A here. Suppose this is B, then this is C, and this point is D. So here AB and CD are 2 different buildings. They are kept in the, or they are constructed in the same horizontal level. So now what exactly is given here, that one person is sitting here at A and he is looking at the top of the other building as well as looking at the bottom of the other building, right? Top of the other building and bottom of the other building. So now, obviously, for seeing the top, he has to raise the vision, that is angle of elevation. For seeing the bottom, he has to lower down his vision, that is angle of depression. So here it is a problem where we are getting the involvement of 2 different concepts. One is angle of elevation, another is angle of depression. So to tackle both of them, you already have to know that always you have to draw a horizontal line, an imaginary horizontal line through the eye of the object. So that is the first thing you have to do. So we have drawn it. We have drawn it. That is a horizontal line we have to do. Otherwise, what will happen? You may miss the angle of elevation or angle of depression. So after that, if a person is sitting here to see this point, so this line is the horizontal level and this will be the line of sight. So this angle will be angle of elevation, and once we join this, then this will be angle of depression. So I'm now going to add them up, right? That lines we are going to draw now so that we can see the angle of elevation as well as we can see the angle of depression. This is the very crucial part of the whole question, because many a times it has been observed that the students commit a mistake over here only in identifying this. Now, as it is a general question model, so I do not want to fix any value for the angle. Rather, I'll write this as alpha and angle of depression as beta. And at the same time, I would like to define the height of the tower where the person is sitting, right? Where the person is sitting as small h meter, right? So my question will be here to find what is the height of the other tower or other building C. So this is the model. Sometimes in the model, what change we can make? We can give you the height of CD and we might ask you what is the height of the other building AB. This is the only change we can do in the model, right? So here now we have to proceed. So What we do, we give a name to this particular part. Say it is E, so that now we can have a complete figure, and in this figure we are going to find this particular height, right? So you can see here this line is parallel to this. These two are already perpendicular, so this is going to construct a rectangle. So if this is H, this part will be also H. So what I need to find is only CE. Once I determine CE, then I can add it with H to find the complete height. That's the problem what we have to do. So this I'm marking it here. This is H, right? This is the complete figure here we have done. Now I have to find what is CE. So now I'll be proceeding for this statement. When we do actual problem, then we'll do. Otherwise, I'll not write the statement for this particular model. Right? So now in triangle, okay. First of all, you write about this clearly. Clearly, A B D E is a rectangle. Therefore, AB equal to ED equal to H. This is already given, right? H meter. Also, you can easily write that BD equal to AE. These are the observation which you make. Now, what I need to find? I need to find CE. So for that, you apply in the triangle ACE. Okay, here now there is a question. What we have to apply? It is 10 alpha you have to apply. Kyo? Because AC there is no such involvement. You can see from this only. So we'll take 10 of alpha. Okay, if we take 10 of alpha, this is going to give you P by B, that is CE by AE. Now here, if we do the cross multiplication, we will be getting CE is equal to AE into 10 alpha, AE into 10 alpha. So you keep marking this. Now from here, what you'll do, this AE, if you can find from the other triangle, then you are done. Now AE is equal to BD. So if you even find BD, then also your task will be over. So now we are in the way to find what is BD. Right? It is BD. So you can start with in triangle. What is another triangle? It is ABD. Again, same idea. In ABD, can I say that this angle is beta? Yes, we can say this is alternate angle, right? So directly you use tan of beta. Tan of beta will be equal to again what? Perpendicular by base. That is AB by BD. That gives you. I need here BD. Remember it, because BD and AE are same, and in equation one I need AE. That means I can find BD. So this is going to give me H by tan of beta. Now here in this particular H by tan of beta, see everything is known. Everything is known, right? So everything is known. So this value I can use in the equation one. So now use this in equation one. So if you use this in equation one, CE will be equal to AE will give you what? H tan alpha divided by 10 beta. So this is what we have arrived at. This is what we have arrived at. So now only one more small part is there. That is now find the actual height. Therefore, CD is the height of the other building. That will be what? DE plus CE. DE is H, already you got to know. At the beginning only you have that. And now this you got as H 10 alpha divided by 10 beta. So now what you will get here is 10 beta. H you can take common, and here it will be 10 alpha plus 10 beta. That's it. That's the problem. Please see. Please see that. If you have any question, queries, you can ask. Otherwise, I'll go to the next one. You note it down comfortably. Okay, great. So we are going to the next part for model number 7. Model 7. Sorry, model 8. Model 7 is done. Model 8. This is a very, very important model. I have seen students committing mistake here in many times. This is very, very important model. So in this model, let me first draw a figure and I'll explain you what exactly is this model, right? So I'm going to explain you this. This is the horizontal level, that is true. This is the horizontal level. But this time in this horizontal level, we are going to consider this is there is a tower, say it is a tower, right? There is a tower. Horizontal level, it is the sea level actually. We are going to consider this as sea level, remember it. And this is the watchtower, suppose, right? That is the watchtower. We have a watchtower over here. Let me just write the name of the watchtower. Suppose this name is EB. We have written comfortably the watchtower as EB. So, what we are going to do from the watchtower, one person is there at the top here, and he is looking at an object here. Say sun. Sun is here. So from here he is looking at the sun. So he is raising his vision. So angle of elevation will be there. And just in this sea level, you will see its shadow coming. So he will lower down his vision. So it will be angle of depression. So this is the thing he is going to do now. Now what is critical about this, right? That I'm going to tell you. First of all, let me show the sun. Say this be the sun. This be the sun, right? That is the sun here. Okay. So here we have this sun. So this sun has been viewed by this person from point A. So from here he is looking at this. So this is the angle of, this is going to give you the angle of elevation. So angle of elevation, again I am trying to tell you, if a viewer is there, application of trigonometry, first thing you remember, always through the eye of the viewer there should be a horizontal line. If you do not draw that, then your whole problem will be in fact wrong, right? You will not be able to make it correct. So without much delay, let me draw the horizontal line. So now, once I draw, at this very moment, I can say that angle of elevation, suppose it is alpha. As it is a general model, I am doing that, right? So now, the sun will have the image, right? Now, what fact we have to use here? That if I treat, obviously, the surface of the sea will be treated as a plane mirror, right? So I have given that effect by drawing that physics idea. So the top surface is the mirror, plane mirror, and you know that plane mirror always reflects the object in such a way that image distance and object distances are same. So from here, whatever distance will be there, similarly below at the same distance you will be getting the image of the sun. So this will be the image. Suppose this is the image of the sun, right? This is the image of the sun, right? This is the image of the sun. Now, image of the sun is also being viewed by that person from the point A. So you will join this so that we can say what is the angle of depression here also. So suppose that angle of depression is beta, right? Also, one more thing we have to join so far. Till now, I did not tell you only what is the question. Now I am going to tell you. So we join this. Now question will be coming, right? Now question will be coming. I'll be giving you what is the height of the tower. What is the height of the tower? Or rather you can say at what height you are observing or you are sitting at the point A and you are observing the sun and the image. So after doing that, I'll be asking now what will be the height of the sun from the surface of the sea? What will be the height of the sun? Right? Of course, very practically it is not a good thing because sun will be at a very big height, right? So, but just to see the problem, we can say it to be a kite also. We can see it to be a bird also. But for example, I just kept it as a sun. So now here also the same observation you can do. Here all these angles will be 90 degree. So A, these points we can name it, right? If we want means we have to name it. Otherwise we will not be able to do the problem. This be E suppose, and this be F, and then sun. Suppose it is let me name it as S only, right? And then image suppose I write say P. So these are the things we have named. And now we have to find what is the height of the sun from the surface of the sea level. That is, in the question, we have to find what is SF. SF is what? By the time we know what is AB. Actually, the problem, this model problem is similar to the previous problem only. Exactly same. But there is only a difference. The difference is that the figure, right? Here, in this figure, what we'll be getting now, I am going to do. Have you finished the figure? Have you finished the figure? If you have finished, please raise your hand. Okay. So now I'm going to do the problem. See here. So my target is to find SF, but out of that EF is already known to us. So clearly, I'm writing clearly AEFB is a rectangle. Is a rectangle. Therefore, I can say AB equal to EF equal to H and BF equal to AE, they're equal. Okay. So to find the height of the sun, all that I need to find is only SE. We have to find only SE. That's the thing. So for a moment, I can consider this SE to be X. Let SE equals X meters. Okay. Then what will be the total height? SF will be equal to X plus H. And also PF will be equal to X plus H. Right? Because why? What is the reason? Since SF equal to PF. Since SF equal to PF. Right? Now, like the previous case, just start doing uh, taking tan theta. So in triangle ASE, if I take tan of alpha, what will I get? Perpendicular, that is SE by base. Base means AE. So now here also, if I cross multiply, I'll be getting AE here into tan alpha is equal to SE. Now here I have to find AE like the previous case. That's all. AE means some value will be there. Let us try. Also in triangle, another triangle you consider. What is the other triangle? APE. What is the angle here? It is tan beta. Tan beta perpendicular will be what? PE divided by AE. Great. So from here we have to find AE and we have to put it there. So tan beta will be coming here. But now what is PE? Right? Look at PE. PE is this portion. Out of that, this value is x plus h. Already you did. This is h. So total value will be x plus twice h. So directly I can write this because I explain you. So directly I'll write this as x plus twice h. X plus twice h, right? Now from here, we already got, I need to calculate only x. Remember it. X is the quantity which I need to find. Now let us put this here. Therefore, 1 implies 1 implies. So SE will be equal to SE will be equal to KE, that is, this is here divided by 10 beta, and then what is the value here? 10 alpha. 10 alpha. Okay, right? So we have found it here, right? So we have found SE. Now what will be the total height? Therefore, SF will be equal to SE plus H. So SF equal to SE is x plus twice h divided by this into 10 alpha. Acha, right? So now will it be the result? Because we are getting mixed with many quantities. I have still left, I am still left out with x, right? I need x only, right? So actually this is a funny step I did, funny step, sorry. This step you remove, this step you remove, the last step you remove. This is going to be a funny one, right? In the previous only we can do dot here. So here SE is equal to, you considered SE equal to x, right? So SE is equal to x. So this is x plus twice x divided by 10 beta into 10 alpha. Now from here you first find what is x by doing the cross multiplication. It is x 10 beta equal to x 10 alpha plus twice h 10 alpha. Now from here if I find the h, you see what will be there? Not h, x we have to find. H is given. So this will be 10 beta minus 10 alpha. Can you see? This is the x. X means which portion it is? SE is there. That is SE. So here I will now conclude. Therefore, total height of the sun from the sea level is SF. And SF means what? X plus h. So x value is already there. This is twice h 10 of alpha. That is 10 of beta minus 10 of alpha plus h. So now you can finish this problem. 10 of alpha here. So in one step I am going to solve it. H will be taken common, right? So here what will it be? 10 alpha h 10 beta. What will we get? 2 10 alpha minus h 10 alpha. Okay, 10 alpha. Here will be actually getting 10 beta plus 10 alpha. So this is the ultimate height. So this is all about the question. And this is what a very important model is. This can be given as a question itself. This can be given as a question itself. So I give you time, you note it down. I'm going to the next model now. Model number, this is the last model. Model number 9. It is also important. In this model, first let me create the model, then I'll tell you what exactly you have to do. This is the horizontal line. Then we'll be having two objects here. One object here and another object just vertically below here. One object at the top, one object just below, vertically below. So these objects are named as A and B. It is B. Two objects are there. They are vertically below each other. So let me join them. So this will be giving you a perpendicular line. Fine. Now, actually, what type of objects may be there? In problem, we might say that there are two birds at a certain point of time. They are just coming vertically one above the other. Maybe there are two helicopters hovering just vertically above other one, right? Two flights are going at a particular point of time. One flight is just coming vertically above the other. These are the cases what we can say. And one person will be there who is observing this two at that particular moment with two different angle of elevations. From here, if you will see, this will have one elevation and this will have the another angle of elevation, right? So suppose the angle of elevations are alpha and this be suppose beta. And we are saying that the position of the man be defined by the letter C and the point where this vertical line will meet the ground is D. And now only one given information will be there. The information given is that the object B, suppose it is at a height of h meter from the ground, h meter from the ground. Now question is that what is the distance between, vertical distance between the two objects? That means question is to find what is AB equals. And this is a model tree, right? So process is same. You can see that there is no utilization of the hypotenuse here. So directly you can write now this, if you want you can write AB as X also, but AB only once will use, so I will not write this as X. Let it be AB only. This time directly I'll apply the triangle. In triangle AB, sorry, CBD. In triangle CBD, CBD, in triangle CBD, in triangle CBD, tan of alpha equal to BD by CD. Tan BD, what is the value? H. And CD is here. Okay. So you find what is CD equals. CD equals to these things. Right? Because here the unknown quantity is CD only. BD is already known. Also, you now take the bigger triangle, triangle ACD, and here you take tan beta. Now you see where the students are committing mistakes. When we say that angle of elevation of this point from C, they mark this part as beta. But remember, always angle of elevation and depressions are measured with the horizontal. Remember it. Always remember. Otherwise, you will commit mistake. So tan beta will be equal to here what? AB plus BD divided by CD. So here all the values are known to us. This AB is the part which we need to find. BD is H and CD is H by tan of alpha. Now you have to only simplify this, right? You have to only simplify this. So better you see there are two H. That means both the sides will be containing H. So we have to simplify this. So this is AB plus H whole into 10 alpha divided by h. Now do the cross multiplication. It is h 10 beta. Then it is, we are interested to find AB, remember it. So it is h 10 alpha. So from here, what you can get, AB 10 alpha is equal to h 10 alpha minus, sorry, 10 beta minus 10 alpha. Right, what I did, that this part I kept separately, and this h10 alpha I have taken to the right side. So yes, you are done, you got the height. So it is h, this what I did as a model. These are actually problems, general problem in your application of trigonometry. So we are done with this. This is the required height. At last we have to write the conclusion, that I am not writing, that is for you. So this is the required height, or you can say distance, vertical distance between the two objects. So you go through it and you write it. So let us start with question number one. I'll mark this as question number one. Right. So you can write this, that the angle of, please hold on. There is a phone. I'll receive the phone and I will come back to it. Okay. So the angle of elevation of an object as viewed, sorry, as viewed from 2 points. I'll draw a figure, right? 2 points A and B, right? In the opposite side of C are complementary. Then find height of D. Where is D? This object is D. Object D, right? So here we have to draw a figure. I draw the figure first, and then we'll do the question. This is the horizontal line, and there is a object at a height. We do not know what is the height. That height we have to find. This is the object D, and this is the point C. They were talking about. Now this point D has been, this point D has been viewed from two different points. One A, another is B. And whatever is the angle of elevation, they are complementary. So let me name the point as A, and this is B. Okay, there is one small information left out that I'll write there. First, let me finish the figure. So angle of elevation they have said, that means this you have to join, and from here they have to join this. Now just try to remember, they are saying that these two angles of elevations are complementary of each other. So if one is theta, what will be the other? It is 90 minus theta. I have to find what is DC, right? That height of D they are asking. Only one thing I missed out, that I'll write after this. You write where you write AC equal to small a and BC equal to small b in meters, suppose. So this is what the given part is. Now we have to find the height. Okay, we have to find the height, right? So one more thing, you mark it here. This distance is A, and from here this distance is B. This must be rightly written. This is A, this is B. We have to find what is C. Now you see again here there is a small observation. As I told you that the maximum problem, there are very less problem where hypotenuse will be used. So it means maximum problem will require only the uses of tan theta. So here also we need the uses of tan theta. So in triangle ADC, ADC, you apply tan theta. What will be tan theta giving you? CD by A directly I have written. Okay. This you write like this only for a moment. In triangle BCD, you apply tan theta. That is tan of 90 minus theta will be there. So that gives you again CD by B. So applying the complementary formula, what you will get? This is cot theta. That is equal to CD by B. This is number 2. Very good. Now you see what is the value of tan theta into cot theta? It is 1. So now you put the value. Tan theta means CD by A. Cot theta means CD by B equal to 1. So CD square is equal to AB, and this will be equal to root over AB meters. So you found the required. So that's the solution of the problem. That's it. That's it. Please. Now we are going to do the another important problem. Only one question I'll do for today. Then we'll go for the next class. So this is a question you write. It is very, very important. If the angle of elevation, if the angle of elevation of a cloud from a point from a point 8 meters above a lake above a lake is alpha, and the angle of depression angle of depression of its reflection in the lake B, in the lake B beta. Prove that the distance of the cloud, distance of the cloud from the point of observation is very important question. 2/8 sec alpha divided by 10 beta minus 10 alpha. That's it. That's a very important question. Please note it down. We'll be doing it. So now actually this is very much same as the model today we did. So for a moment I just want to go back to the model we did, right? Then we'll be trying to see. Just I think it was the eighth model. This is a model. Right here actually they are asking you AS. Here it is a cloud. Right? So we are going to redraw the figure. So we'll redraw it. We have to do. So this is the horizontal line, or rather you can say this is the level of the sea. This is the lake level, water level. So you are going to consider a point at a height of h. So this is the point, right? So as per our convenience, we can give the name. This is the point A. This is the point B. From A, you are looking at a cloud, right? So suppose this be the cloud, this be the position of the cloud. So what will be its reflection? Its reflection, as you know, it will be exactly below it at a distance, same, right? So this is the cloud. So this cloud, suppose I want to name as C, and the reflection, suppose I want to name it as D. Sorry, D. Now these two are joined by a straight line. These two will be joined by a straight line. Now what is given? Angle of elevation of the cloud as viewed from the point A is given as alpha. Where is the alpha? Above like is alpha. And angle of depression is given as beta. And this height is given as h. So you have to find what is AC. So first you join these lines. So first of all, do not forget you have to draw the horizontal line. Otherwise it will be wrong. Then this point and this line and this line. And you mark the angles. Now you mark the angles. This angle is given as alpha. This angle is given as beta. Fine. So problem is already ready. Now here it is suppose E, and then here it is suppose F, right? So what we'll be having here, this particular value is H. This particular value is H. So all that you need to find is AC, right? You have to find AC. Now this is the first time. This is the first instance. Actually, these problems are easier because you see here. I just want to tell you that you have got a hint actually. Here you see sec theta is already there, sec alpha is there. That means somewhere or the other you have to use the sec alpha. That's all, sec alpha or cos alpha, because in that case only you can relate this AC. So anyway, now we'll start. See, tan alpha is also there. That means tan you cannot avoid. So in triangle ACE, I'm doing it quickly. Tan alpha will be equal to what? CE by AE. CE by AE, right? So CE, there is no value as such for the time being. So if we want, we can write this value as X if we want. So let me write it as X. AE, let it be like this only. Tan alpha will be equal to X by AE. Okay, for a moment, let us keep it like this as a resource. Another triangle you consider ADE. In this, you find tan beta because these are needed. Tan beta will be equal to what? It is DE divided by AE, right? So this is here. Now you do one thing. Tan beta. What is DE equals? DE will be equal to DF. DF means X plus H. And with that again H will be added. So it will be X plus twice H divided by AE. See, for the time being, this AE is not a required quantity for us, right? So AE you replace. From where you replace? From this quantity you can replace, right? This is one of the very important part, right? And one more thing, you try to see from the figure also. Sec alpha. Sec alpha or cos alpha, it will relate what? Base and the hypotenuse. Base and the hypotenuse. What does that mean? That means if I now replace AE here, I'll not be getting place to replace the AE obtained from this cos alpha. Are you getting? This is very important. So before you do any step, last step you first do. Again, also in triangle ACE, triangle ACE, you take sec alpha. sec alpha is h by b, that is AC by AE. So here, this is what my target is, AE. AE is equal to sec alpha. AC equal to AE sec alpha. Now I have to find from these both equations the value of AE, not X. Remember it. Are you getting what I'm saying? Because till the last moment you have to keep this particular AE alive because you have to replace it here. So from 1, what you can find as X, I could have kept this result like this only, AE 10 alpha, and this you apply in number 2. That will give you 10 beta equals X plus twice H divided by AE, sorry, X value I have to replace, I'm sorry, here I have to replace, value of X I have to replace, that is AE 10 alpha plus twice H divided by AE. So from here you have to find what is AE, then you are done. AE, can you find it directly? Can you find it directly? If you do little work, you can do easily. See how we'll find this. I multiply with AE. I'll show you by spotlight. AE I'll multiply here, so it will be AE 10 alpha. This I'll take that side. So AE 10, sorry, AE 10 beta minus AE 10 alpha. AE, if I take common, what will be left out? 10 beta minus 10 alpha. So ultimately this will come down here. And right side what will be left out? 2H. Great, हो गया. Right? अब लास्ट वाला क्या है? E इसमें जो है, this I'll mark as star. Therefore star gives AC equals, see, if you put the value here, 2H sec alpha and henceforth. So that's the answer. This is a very, very important problem from exam point of view. Please be very, very alert. It is an important problem from board exam. It came also in some year. I'll tell you the year also. It is CBSE 2004. It is a problem. After that also it came. The book I took is a old edition book, so I cannot get the recent ones. Right. So whenever you will